Hi everyone, welcome to General Chemistry. I'm super happy to see you here. And so when we're talking about chemistry really studies how matter and energy interact and recombine. And I don't have a good picture of the sun, so I decided to give you a picture of some leaves because I want you to remember that leaves are an example of matter that has been generated through energy absorbed by the sun or from the sun by these plants that have put a lot of work into making these leaves. And then they fall at the end of the season and then they become different kinds of matter. And we have a lot of interconversion between matter and energy. And in fact, everything that is alive is something that is doing chemical reactions constantly to sustain their lives. Whether it's a bee or whether it's a tree that's making flowers, everything that we see, feel, smell, and do is because of chemical reactions taking place. And there's chemistry in everything. And in this course, we're going to discuss how we classify matter and energy, and we're going to learn about different types of chemical reactions and how energy flows during those chemical reactions, and also how matter recombines in these chemical reactions. So we're going to start with a quick overview, and I'm going to switch over to an image from our textbook. Because when we talk about matter, we need to think about how we classify it. Now, I'm making these content as videos, and so if you're already familiar with some of the material, you should feel free to skim or multitask and just listen to the video just to make sure that you didn't miss some content. You can always pause and come back a few seconds or minutes if you realize that you've missed something. But this is one of the advantages of having this content material as a video, because it means that you can really move at your own pace in a much more effective way. All right, so we're eventually going to understand that all matter and energy can be converted from one thing into another. But for right now, we're going to classify matter, and we're going to focus on thinking about things that have a physical form. And if they have a physical form, then they are made of matter. And our first division is between pure substances over here and mixtures. So when we talk about pure substances are materials that have a constant composition. And I'm going to go ahead and write this down for you, just in case you need it. So pure substance these have constant composition. So that means if you take a part of it off and you do stuff to it, if you melt it, if you change its phase, it's going to stay having the same composition. And pure substances can either be made out of elements or they can be made out of compounds. And we haven't really talked about atoms yet, although you probably already know what they are. But elements are materials that can't be chemically broken down into other materials. And the chemical part is really important. So it doesn't really matter what you do with it, you can't break it down further. But compounds are made of two or more elements, and they can be broken down into other more simple things, either into elements or into other compounds. Sometimes I write too fast for my stylus. Okay, so if we go back over to our picture, we can see that we've followed this left-hand example. Our pure substances can be elements like pure gold, or they can be compounds like this example of ice, which actually has some liquid water there as well. So over on the other side, we have mixtures. Now mixtures are made of two or more pure substances, and these substances that happen to be mixtures can be physically separated from each other. And this is one of the keys, that rather than that chemical separation that we're able to do when pure substances are compounds and we can break them into other things like elements, with mixtures, we can physically separate them from the other parts in the mixture. And this is the main piece that is going to allow us to tell the difference between pure substances and between mixtures. Now, one thing I want you to sort of remember in the back of your mind is that people were able to tell what pure substances, what elements, in many cases, versus compounds were before they had any understanding of what some of those elements were and any understanding of what an atom is. So these are very fundamental ideas. And you don't have to understand what an atom is in order to get to this part. Okay, so we were going to write down that mixtures have two or more pure substances that can be physically separated. And when we talk about physical separation, we're talking about things like filtration or distillation or just, picking rocks out of the sand, things like that. When we talk about mixtures, we had two additional separations for them. We could have a homogeneous or a heterogeneous mixture. And if we have a homogeneous mixture, this is a material that is made of things that fully dissolve in each other. So these are thoroughly mixed and dissolved. And so you can have solid, or you can have liquid, or you can have gaseous homogeneous mixtures. A solid mixture might be something like stainless steel, because the important part is that these have uniform properties throughout. It doesn't matter which part of the sample you are studying, they all will have uniform properties. So an example of a liquid homogeneous mixture might be something like seawater. And a gaseous homogeneous mixture could be air, where the sample of air, because those gas particles are moving around, is always going to be a homogeneous mixture. So a heterogeneous mixture has multiple phases usually. At the same time. And the properties are not uniform throughout. So if we look at the page from the book, we can see that their example of what a homogeneous mixture here is a solution. This is a liquid-based solution of vinegar. It is a solution in water where the vinegar is dissolved in the water, and there's a bunch of other things that are dissolved in it too, but it's all dissolved. Now over here on the heterogeneous is a salad dressing where you can see the separation here with the oil on top and the rest of the water-based layer at the back. Okay, so we've got some basic ways of classifying matter here. We're going to study the structure of atoms a little bit more later, but for now, it's just enough for us to remember that we know that particles are sort of at the fundamental layer of our understanding of what atoms are. Okay, so a few other reminders. We know that if we have atoms as our fundamental sort of particle of matter, it's not the smallest one or anything, we can continue to separate them, but we have elements made up of individual types of atoms that are unique to each of those element types. And elements, the atoms of an element will behave in distinct ways that are different from other elements. And that we can combine atoms together to form molecules, because they are making chemical bonds. And so we're also going to study the periodic table a little bit later, but most of us are familiar with enough different elemental symbols that we can talk about chemical formulas here, because we're going to use them extensively. And chemical formulas give us an idea. For example, if we see CO2, most of us, even if we aren't scientists yet, know that this is carbon dioxide. And this chemical formula tells us what the ratio is between different elements in here. And so this 2 right here indicates to us that we have 2 oxygen atoms. And we have no subscript here, so that means we have 1 carbon atom. And together they make 1 molecule of CO2. And this ratio of 1 carbon to 2 oxygen atoms is consistent. That we always, anytime we have carbon dioxide, we are always going to have a 2-to-1 relationship of the oxygen to the carbon. And this ratio is known as, or this consistent ratio, this is known as the law of constant composition. That you can actually use masses and mass ratios to study what a material is, and you can figure out whether it's the same or whether it has the same mass ratio, and therefore it might be the same compound that you already are looking at. Okay, so the other thing that we use when we're talking about materials is we use phase symbols. And we're going to use these so commonly that I'm going ahead and talking about even this really fundamental information here. Our phase symbols tell us whether we have something that is a solid. We're going to use an S. If we have a liquid, a pure liquid, we'll use an L. If we have a gas, then we'll use a G. And if it's a solution dissolved in water, then we use AQ for aqueous. It's not just any solution, it's a solution dissolved in water. And we're going to talk extensively about solutions later, but these are just introductions. The next way that we're going to classify matter is by looking at their chemical and their physical properties. So, chemical properties are things like, what do these materials do when we mix them with certain chemicals? So how does the matter behave? Does it burn? What does it do when it's combined with water? Does it conduct electricity? Actually, that's probably not a chemical property. So how does it act chemically? When we're talking about physical properties, these are usually things that we measure. So these kinds of properties would be things like the temperature or like the pressure of the system, how much does it weigh, all kinds of different things. So when we classify physical properties, then these, we typically will divide these into intensive versus extensive properties. And intensive properties, these don't depend on sample size, like temperature. So it doesn't matter, if I have a big jug of water And I take that jug of water and I pour a little bit into a beaker, and then I pour a bunch more from the same water bottle into a larger one. And I take the temperature of both of these. They're going to have the same exact temperature. It does not matter how big the sample size is, because temperature is an example of an intensive property. An extensive property, you probably can figure out, does depend on the sample size. So, for example, if I were to look at these samples of water and I were to determine the mass of each of those water, you know that the one that has more water in it is going to weigh more. The same thing is true about volume. If I took the volume of both the small amount of water and the large amount of water, we know that the large amount of water is going to have a larger volume. And so these would be examples of extensive properties. The interesting thing is that if we take mass and we divide it by volume, this is something that is called the density. And the density is one extensive divided by another extensive variable, and it becomes an intensive variable. And this is always true. If we divide one extensive variable by another extensive variable, we're going to get an intensive variable out of it. Okay? So this is a good place for us to talk a little tiny bit about physical change. So if we're looking at physical change, we're talking largely about the transition between solid going to a liquid, liquid going to a gas, and a gas going to a solid, or vice versa. These are all of our physical changes. Well, they're the main ones that we're going to focus on. So any of these different physical changes, these are reversible for any given material. So if I take a solid and I turn it into a liquid, then if I freeze it again, it's going to go and have the same exact physical properties that it had before. So any of these physical changes are going to affect some of the physical properties, but never in ways that are permanent. All right, so this little whirlwind trip took us through Chapter 1, Sections 1.1 through 1.3, and then 1.5 and 1.6. So I'm going to continue with Chapter 1 in my next video.